Hello, this is for Chem 103, so welcome. This will be our first stream of the second module, and I'm going to discuss these activities that you see on Blackboard that you'll be completing throughout this module. They're a little different from a standard worksheet, so I just wanted to talk a little bit about how they work and what the best way is to actually go through them. Some of the questions seem a little like almost too simple, and there's a reason for that, so we'll talk about that. Those of you who were in lab yesterday got kind of an intro to this first one about matter, but this will give you a little bit more detail and help you to really hopefully learn that stuff well. If you're here watching live, you're welcome to comment. I'm trying to monitor the YouTube comments. You can also message me on Discord, and I've got my phone up here too. So hopefully we can get your questions answered as we go through this. General structure here is I'm going to kind of go through, give you some ideas about this stuff. We'll do a couple of the questions together just to get you started. Then throughout this week and next, I would expect that you work through these. They each culminate with some problems at the end to like figure out some questions. And so if you could try those out, and then next week, same time, I will come back on here and kind of go through all the answers so you can check and make sure that you've got everything right before everything's due on Friday. So, all right, let's get started. Okay, so the way these things work and the way they're a little bit different from a standard worksheet is the idea is this isn't meant to test your knowledge. This isn't meant to check what you already know. It isn't really meant to go along with this textbook. It's meant to actually teach you the concept as you work through it. So just by going through and doing this the way that it recommends, you are getting the information, and you're actually getting it in a way that is more permanent and better than if you were to read it or listen to me talk about it or something like that. So these always start with just kind of giving you some information without context. So this just says Model 1, examples of various types of matter at room temperature. And it gives you a list of types of matter, a classification of those using words you may or may not know, and then their states and their formulas. So that's all. That's all it gives you. It doesn't really explain what's happening in here, like what these things mean. It's just giving you information. And then the questions that come right after the model are meant to make you think about the information in such a way that you can actually figure out what's going on without them explaining it. So, for example, the first question here says, how does the formula of an element differ from that of a compound? The idea here is not for you to go look that up and write some definition that you find. What you're supposed to do here is look at the table, look at the information that's given above, see if you can figure out how the formula of something considered an element differs from something that we would consider a compound. So let's take a look, and we've got the first one here. Aluminum is classified as an element, hydrogen's classified as an element, and then water and table salt are classified as compounds. And so then we can look at some similarities and differences and try to figure out how a formula of an an element differs from that of a compound. So we go over to this formula column and we look at these formulas and we say, all right, well, what do the elements have in common? What do the compounds have in common? And you might say, you might notice that the elements are made of just one thing, one element, whereas the compounds seem to be two. So you might write something as simple as elements have one type of atom, compounds have two. Now, is that an exact correct definition of what elements and compounds are? Not really, and we'll see why, but that's okay. The idea of these is not to get the absolute right answer in every question. The idea is to think about this stuff and try to figure out these rules on your own. Try to see if you can come up with these rules. So, how you can distinguish elements from compounds based on their chemical formulas, that's kind of a similar question in number one. And one thing that can be a little confusing sometimes about these activities is that the questions are sort of similar. But you can see this question one asks you just a very direct, simple question. How are these things different? And then question two is saying, can you come up with more of a general rule that distinguishes elements from compounds based on their formulas? So what's the most kind of general or useful rule that you could come up with here? You might say anything that is only made of one type of atom is an element. More than one is going to be a compound. So it's a more general rule there. All right, so then you're going to do the same thing with the next question. How does a pure substance differ from a mixture? So we go back up to the table, and we notice that pure substances down here are defined as elements and compounds. So how do these elements and compounds differ from these mixtures? And so you're going to look at the various formulas and stuff and see if you can figure that one out as well. And I think you probably can. Again, these questions aren't meant to be hard necessarily, but they're meant so that you can start thinking about what do these definitions mean rather than just being told the definitions and asked to memorize them or something. You'll learn them better if you go through this the way that it's meant to be done rather than just trying to memorize something. All right, so that's basically how this works. You go through, and then at some point they give you some information. So that would be down here, this information, and this kind of summarizes everything. So just in case you got some stuff wrong or you didn't quite understand something, here's where you have all the actual information, kind of like a textbook. But by not looking at that first, you give yourself a chance to engage with it in a more meaningful way that will hopefully lead to better long-term understanding. So don't jump right to the information. Figure it out. Try to figure it out on your own first, and then come down to the information. Another thing is these activities work really well in groups, and they're really designed for that. And when we were in class, in person, we would always do these in groups. And so if you'd like to do that, you're welcome to. If you want to get together with some people from class, you can meet up. You can ask for partners on Discord, or maybe you've talked to each other in lab and you have some personal information. You can talk to each other to get together. If you're comfortable meeting in person, that's really up to you. If you would rather, do it virtually in Discord or in a different chat area, that's fine too. But they do work nicely together. And if you do work together and you want to actually just complete one thing together, that's fine. You can put everybody's name on it and just have each group member upload the digital copy so that I have a record in Blackboard of each person doing it. But you're welcome to work on it together. That's fine. All right, so you'll go through and kind of work on this kind of stuff. Most of this is pretty straightforward. And then really the kind of key summary for this one is right here, number 3. This is what you want to ultimately be able to do. Can you look at some different things and first classify them as either a pure substance or a mixture, and then if it's an element or a compound, if it's a pure substance, or homogeneous or heterogeneous if it's a mixture. So you want to be able to do that. And then just kind of understand some other things about elements and formulas and how we put these atoms together to make compounds. So you'll see that. And then the ends of these things always say, like, read pages in your book and work assigned problems. We don't have a separate book or anything, so you can skip that. You can also skip that. We're not going to memorize elements in this class. But the rest of it should be good. I'm not going to grade these like point by point on making sure you got every question right. These are meant to be activities to help you work through and learn the material. So it's to your benefit to work through this as best you can rather than just looking up the answers or copying it off an old version or something and turning it in. The point of this is to help you learn this material. So please work through them. They shouldn't take you that much time. Let me know if you have questions. And again, I'm going to come back on next Thursday and discuss the some of the answers for these. So So for those questions, if you haven't had a chance to work through it by then, I would encourage you to not just pull the answers off of the video, but to actually think it through for yourself. Again, I'm not grading these on accuracy. I want you to use this to learn the stuff. All right, let's jump over to the other one, the atoms activity. Also for this module. So in this one, we have another model. So another thing where they just sort of like throw some stuff up there that may or may not make any sense. And then they like tell you some things down here in the bottom, and then they start asking you questions about it. So all of the questions again here should be answered using the information on this first page. This one in particular, I really want you to do it this way because a lot of people I've noticed coming into this class have some misconceptions about atomic structure. So stuff that maybe got turned around in your head or that you learned wrong in a previous class. Sometimes it's just something that I've noticed a lot of students having some confusion with. It's not hard material. It's something you'll pick right up once you kind of go through it. But let's all work through it and make sure that we know the correct way of thinking about this stuff right now so it doesn't confuse us later. So for each of these pictures here, you're given some dots, and then there's a legend up here that tells you something about those dots, so you can see that they have some protons, some neutrons, sometimes not neutrons, and an electron or not an electron. You've got some symbols given here. You've got some names given here, and some numbers down here in AMU. Those are some masses. As the atoms get bigger down here, they do some counting for you because it's hard to pick out every individual particle, but you can see the electrons still have to count them out. And then you have a little bit of information down here. The hydrogen 1, 2, and 3 are isotopes. Carbon 12 and carbon 13 are isotopes. We can write these this way. And the nucleus of the atom contains the protons and the neutrons. So the first part of doing this then is just going to be counting some particles. Right? So it says, look at schematic diagrams for carbon. What do all 3 carbon atoms and ions have in common? So we're going to look at this middle row of these 3 carbon atoms first. And we're going to say, okay, well, what do they all have in common? Well, they're all called carbon. That's something. They all have a C in their symbol. And then if we look at some of the particles and numbers, they don't have the same masses down there, so that's not a similarity. They do seem to have the same number of protons. They do not have the same number of neutrons. And let's check the electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So they don't have the same numbers of electrons either. So the only particles that are the same in these are the numbers of protons. And so we would write that down here. So they have similar names and they have similar number of protons. All right, and then we're going to do the exact same thing for hydrogen and magnesium. And you might guess that we're going to have similar results, and you'd be right. But go ahead and count them out just to make sure. So then we're going to kind of summarize that. Look at a periodic table. Considering your answers, what is the significance of the atomic number? So if the 3 carbons all have 6 protons, and the 4 hydrogen atoms all have 1 proton, and the magnesium ones all have 12 protons, then we can look at a periodic table, and we can try to find these atoms and see what this worksheet is hinting at here. So if you look at carbon right up here, you can see that its atomic number in the top of the box of the element is 6. Hydrogen's way over to the top left is 1. And magnesium, just down to the right from hydrogen, is 12. So you can see how that correlates to the numbers that we came up with here. And that should tell you something about what the atomic number means. All right, so you'll work through this and continue to answer these questions. Again, consider, even if you're pretty confident, consider that you may have some wrong ideas about atomic structure, about numbers of protons, neutrons, electrons. Something might be wrong in your brain from a previous class, or just getting something wrong. So as you're answering these questions, keep going back to that model on the first page and make sure your answers make sense in the context of these data, not just what you think in your head right now. And then hopefully by the end, you actually have it and you have the right answers and you understand it. So as with before, once you kind of go through this, you'll get some information that'll help you out. And then you've got some exercises at the end. And one of the goals here, kind of like the other one, is this right here. So by the time you're done with this, you should feel comfortable filling in a table like this, where you have a symbol, and then from that symbol, you can get atomic number, mass number, and then the numbers of protons, neutrons, and electrons. And sometimes if the symbol is not given, but the numbers of those particles are given, you can work backwards and fill in that symbol as well. So that's your goal here, that you should be able to figure out the numbers of these different particles and then work with some of these symbols. And as before, you don't have to do any of this extra kind of like memorizing stuff. You will need a periodic table to help you with these last couple questions. And I will come back on next week to go through all the answers here. But hopefully this is a good introduction to how to complete these activities. Again, they shouldn't take you too long, but please actually work through them, ideally in groups, but you can do it by yourself as well, and try to make sense of some of this information. If you're totally lost, it doesn't make any sense to you at all, let me know, send me a message. We can set up some time to meet either online or on campus and go through it. But I want you guys to learn all this stuff. So hopefully everything else is going well. This week you also have another article report to do, an at-home experiment, which half of you should be completing this week and half of you should be completing next week. If I gave you a 0 on your proposal and you did it, it was because your experiment was not approved. So you can revise that, resubmit it, and then do the experiment. If you're in the group B that's supposed to be doing the experiment this week, but your proposal was rejected, you can have more time. You can still do the proposal this week and you can do the experiment next week, or however you want to work that out. You don't have to feel like you have to rush that in right away, but everything does need to be done by the end of next week, so by next Friday. Okay, so let me know again if you have any questions or concerns about any of this stuff. Lab yesterday went well for Group A, so I'm excited to do that again next week for Group B. All right, otherwise, happy chemistrying and stay safe, stay healthy, and have a good weekend. Thanks, everybody.